does was very sophisticated in this animal. This animal actually was able to sense subtle turning movements of the head and probably employed relatively rapid and quick turning movements to keep its eyes fixed on potentially fast-moving prey. Now we're getting up into the beak.
The CT scan of the snout reveals something unexpected.
That's interesting. It's like a cavity in the beak there.
It's totally hollow.
Given the lifestyle of this animal as a predator and how narrow it is, we would have predicted that this hollow space would have been buttressed internally by struts. We don't see that. That cried out for explanation. In fact, that explanation was kind of long coming because it had us really surprised.
Scientists now speculate that Andogolornis clapped its jaws together to create a low-frequency sound.
Low-frequency sounds have the interesting property is that they can propagate over long distances, even sort of over rough or heavily forested terrain. Certainly, this sort of chattering of the jaws with this deep wooden resonating chamber in the snout could have been important for courtship, but it also could have been important for communication over long distances. These are not the kind of things that we can answer for sure, but one interesting thing is that the CT scanning actually raised this whole issue altogether.
The CT scans also indicated something scientists never thought they could predict: the posture of these prehistoric animals when they were wary. There was a clue to this locked deep inside their skulls.
When animals are alert, like when a twig snaps, they tend to orient their head in a very characteristic posture. And it turns out that that posture is in such a position that a particular part of the inner ear is oriented horizontally.